Welcome back guys. Today I'm gonna set up a new sensor that is LPS25HB. Now I will be interfacing the sensor and I will be explaining everything about the sensor regarding its code. So to gain more knowledge about this sensor, let's have a look about the sensor, and the best way is to look over the website that is controleverything.com, and here we have to search for the respective sensor that is LPS25HB, and let's say it's a pressure sensor, as you can see, MEMS. The range is 260 to 1260 hectopascal absolute digital output barometer, as you can see. These are some of its features, and you can also purchase the sensor from here. I will be interfacing the sensor LPS25HB with a Raspberry Pi and a Java code, and to require the Java code, let's have a look over the resource tab, and here comes the Java code sample. Now you can download the code as a zip file from this very site. The link is here. Also you can download the link, the code from GitHub repository that is Control Everything community. Now what we require is to put up some hardware and let's make some connections regarding the working. Let's have it. Now looking forward to make some connections regarding the hardware. First of all, we require our sensor that is LPS25HB, which you are able to see on my screen. Now this here is a Raspberry Pi, and these are the GPI pins of the Pi. Further on, to make a connection among the Raspberry Pi and the sensor, we need an I2C sheet so that we can connect and make certain connections with other I2C devices also, and this connection should be a lot easier. So gently place this I2C shield over the GPI pins of the Raspberry Pi. Let me tell you something, that this I2C sheet is also available on the website controleverything.com. Now we need a connecting cable just like this and make a connection among the sensor and the cable. While making this connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly for the I2C shield also. Now we want to power up our Raspberry Pi, and we need a micro USB cable just like this, and gently put it over the power jack. Finally, we need an internet connection so that we can connect our Raspberry Pi. So an Ethernet cable is required. We can insert it up over the power jack. Also, if we don't have that, we can use a nano wireless Wi-Fi adapter, a USB adapter, as you can see, and we can also use it. So we are done with the connections part. What we require is our code so that we can have an interfacing and working along the sensor. Well, we are done with the connections setup. Now we require to have a look over the Java code so that we can interface the sensor along with it. So to go there, let's log in to github.com, and here search for the repository we want to work with, and that's Control Everything community. Here we have to search for the sensor that is LPS25HB, as you can see on my screen. Get over it, and this is the Java code we are talking about. Now before moving to the code, let's have a look over the instructions we need to follow to make it a success. So we have to download and install Pi4j library on the Raspberry Pi, and the steps to install this library is being provided on this very link. Now open up the link so that we can have a better view regarding the installation steps and the commands we need to follow. As you can see, you have to follow all the commands for installation, and step by step you have to go ahead. Now this is the command to compile the code, and this is to run the code. Please note it down carefully. Now get back to the code so that we can move ahead. So this is the .java extension file. First of all, in the code, you see that we have imported some of the libraries, and we have created a class named LPS25HB. Now here in the function, we have to get the address of the device, the sensor, that is bus.getDevice, and it's 0x5c. Next, we have to set the active mode continuous update on the register 0x20, which is the command 0x90. Now after that, we have a sleep of 500 millisecond, which senses that we have sent a command, and it will take some time to get that command for the sensor. After that, it will respond back, and we have to get that response. It common language, it says that we have to read data back. So as we are reading data back, 3 bytes of data for pressure from the register 0x280 or with 0x80. After getting the values, we are converting the data into hectopascal for the pressure using the formulas we have seen in the datasheet for LPS25HB. As we are done with the writing, reading and converting of the data, we want to display the output results on the monitor on the screen, and we have chosen the format of pressure in two values of the floating point value in the hectopascal unit, as you can see on my screen. So it's a very simple code you need to follow up to show the working, and let's have it. Now comes a very good part that's very interesting, as to see the working of this code, which we all love. Now for that, copy this entire Java code, open up the terminal regarding the Raspberry Pi we have connected through internet, and here create a new file LPS25HB for name and .java for the extension. And here we go. Here paste the code and now save it. Now this is the command to compile the code, as you can see on my screen, and here we go. It's done. Now this is the command to run the code, and here we go. We have the pressure value, as you can see on the screen, in 1002.13 hectopascal. Now it's again there. It's very stabilized. Now when I try to apply some pressure, exert some pressure on sensor, it will change, and it's increasing, as you can see on the screen. It's continuously increasing when I'm trying to exert more and more pressure. So this is how the code works along, Java code works along with the sensor. And why not we have a look over the benefits, the applications of this sensor. So we have seen the hardware connections, explanation of the code, working of the code regarding the sensor LPS25HB. The LPS25HB is a piezoresistive absolute pressure sensor which functions as a digital output barometer. The device comprises a sensing element and I2C interface which communicates through I2C or SPI from the sensing element to the application. These features make it very important factor for the applications like altimeter and barometer for portable devices, enhanced GPS applications, weather station equipment, wearable devices, and a lot more. As you see, you can purchase the sensor from the website controleverything.com, and you can get the code from the resource tab, and furthermore you can download it from there also. Also, you can have the opportunity to download the code from github.com, and the repository there is Control Everything Community. So in the end, I would just like to make it clear that you guys have any kind of feeling like you are left without fully understanding any part of this video till now, you can have your queries on controleverything.com, and you can post your comments on the community page here. Now, if you want some articles, blogs relevant to this video, this sensor, you can contact us on instructables.com, and if you want to subscribe more video tutorials like this, you can subscribe our YouTube channel. In the end, I hope you enjoyed this video and have a good one to yourself also. Thanks a lot for watching.